a shape and a color, and it's going to color the shape, right? So this is pretty simple. We have one shape, we have one color, colors is blue, okay? Now we have a list of shapes in a single color. Again, it's in color blue, and remember, as I said, the default matching is longest list, and this will become pretty clear. So basically what it does in longest list is it takes whatever the last value is of the shortest list, it repeats that value to the end of the longest list, right? Does that make sense? So we've got a list that's 5 and a list that's 1, so to make this list longer, it just multiplies it 5 times, all right? And so imagine that we now have fed in sort of a little bit more of a complicated sublist. So again, it takes this last component, or this last sort of data, and it multiplies it, so you can see what the result is. If we'd chosen the shortest list, this is what would happen, is it would truncate the longer of the two lists. Does that make sense? And then the final option is cross-reference. And so basically it does what it says, it cross-references the two lists. So you get the resulting sort of list of stuff is, it's however many pieces that is times however many pieces that is. So this is 15 pieces long. I would say don't ever use the cross-reference selection, and I'll sort of explain why. It's sort of a holdover from sort of an earlier, more basic version of Grasshopper. And really, and this is what Duncan asked about, the dashed hollow lines represent these tree structures. And let me see if I can sort of explain these. So ignore all of this right now. So this is a simple list. This is the graph command. So essentially what are the graph components? So essentially what it's doing is it's taking each of these items and sort of putting them in their own, let me actually do that.
Are those two real components or just?
The graph one is a real component, the other one is fake.
Oh.
I should have clarified that. So I'm going to try to explain to you something that at first is probably going to seem really opaque, but hopefully it's not, right? So Grasshopper, as we talked about and sort of showed in those I guess what I'm trying to explain is that there's 3 data structures, right? There's an individual piece of data, right, which would have been, right, the square. There's a list of data, which might be the square plus the rectangle, plus the triangle, plus the circle, right? And then there's also trees. So a tree is essentially a list of lists, right? So this is sort of one list. And then we might have another list that's a little bit different, right? And then we might have a third list. Right? So all of these are part of the tree. So again, right, you have an individual piece of data, a list of data, a tree of data, which is a list of lists. So in this example, this probably doesn't make a lot of sense. So remember in this previous example, it sort of treats each one of these, right, as a list. If we convert it to a tree by using this graph command, it treats it sort of runs this command with each one of these. So it does it with the blue, which is what results in that, right? Does does it with the magenta, which is what results in the middle, and it does it with the green. This isn't making sense, is it? Not especially, to be honest.
I understand.
Um,
Is that cross-referencing it? No?
It is cross-referencing it, but I guess the beauty of this is that this, right, this list remains discrete. It's sort of, we can manipulate it, we can call it out specifically, which I'll sort of show you how that's going to be useful, as opposed to when it was cross-referenced, all of those, we sort of lose the data structure. Here we're sort of maintaining its structure, and let me get back to this example, and hopefully you'll sort of see how and why sort of trees are important. So let's sort of complicate our example here. Let's say that there are multiple atriums inside this building. So we have an atrium there. Okay, and go ahead and reference all of these. All right, so Rhino essentially freaks out. So,
Is that speech balloon an error message?
yeah. Turn these off. All right, so here's what's happening. We have this list, which is 3 pieces long. We have this list, which is 7 pieces long, right? So what it's doing is it's doing the longest list matching that we were talking about a little while ago, right? So it's intersecting the first B rep with the first plane, right? The second B rep, but the second B rep with the second plane, the third B rep with the third plane, and then it sort of takes that last B rep, which represents that that atrium space, and it repeats it. And what's happening is because this atrium doesn't exist up here, that's why we're getting a little speech balloon. So what we can do is we can use that graph component, right, that I showed you,